Hello everyone! In this next lesson today, we are going to start looking at speed and density. Specifically in this video, we're just going to focus on speed. Have a quick look here at our I can statements for the day. We are going to be using one formula to solve for three possible unknowns. The first case, we could be solving for speed, we could be solving for time, or we could be solving for distance. Throughout the lesson, we're going to look at this formula that's speed is equal to distance divided by time. So what exactly is speed? Well, speed is actually just the comparison between the distance traveled and the time it takes to actually travel that particular distance. But there is another kind of distance, and that's or another kind of speed, and that's the speed that appears on the speedometer of a car when we are driving. That speed is not really distance divided by time. Rather, it is the speed of the item or vehicle at that particular moment. And we're basically saying if you actually drove for an entire hour at the same speed, you would travel 110 kilometers per hour. And we know this because the unit on our vehicles are usually kilometers per hour, and 110 is what it's pointing to. But just like you saw in the video, that needle is constantly changing as we're moving around because our speed is changing. And that speed is called instantaneous speed. Okay, this might be starting to feel like a physics lesson, so let's actually look at where the formula is. Where the math formula comes in is when we look at the average speed, which is taking into account distance and time. As you may have seen before, a common unit for speed could be kilometers per hour or meters per second. These are all possible depending on how far the distance is and how quick the time is. And since it's kilometers per hour, we know that it's some distance divided by that time. That means the average speed is equal to whatever the unit is for the distance divided by time using the matching unit. And the unit you're using here, let's say for example, if it's kilometers, and if for example, the time here is hours, then you would end up with a speed using the units kilometers per hour. And let's say I wanted to find the distance instead of the speed. Then I will have to multiply both sides by time, meaning to find the distance, I need to multiply the average speed by time. From this formula, let's now look at what if I just want to find time. Well, I would need to isolate it by dividing both sides of the equation by the average speed. That means time is equal to distance divided by average speed. So there's our three formulas that we can use to move around and find any of these three pieces of information. Three formulas may seem like a lot to memorize, so let's look at this visual. In this triangle here, we're going to draw out the relationship where speed is equal to distance on top of the time. So if you draw your triangles like this, you can see, okay, if I want to find speed, I would need to take distance over time. Speed is equal to distance over time. And if I want to find the distance, I see that it is a combination of speed and time. So I take speed multiplied by time. And if I want to find time, I see that distance is on top of speed, and that means it will be distance divided by speed. All right, let's put this into practice with our first example. Erica cycled 80 kilometers in 2 hours. Let's find her average speed. Now, the question is asking for speed. So I am looking for speed in my triangle, and I see that it would be distance over time. So let's plug some information into our formula here. Speed, here's distance. I have 80 kilometers in my question here. And for time, I have 2 hours. Find the information from the question and just go ahead and substitute the distance for 80 and the time for 2 hours. Once you have this, you can plug this into your calculator or do a quick mental calculation. 80 divided by 2 gives us 40. Be careful with our units. The units kilometer an hour, these are not calculated out of the calculation. In fact, they stay and become the units for our speed. So our average speed for Erica is 40 kilometers per hour. Let's look at the second question here. It is now asking, how long would it take her to travel 180 kilometers? Okay, so let's check what information do we have. First of all, we're assuming that she continues at the same average speed. She'll slow down, she'll speed up now and then, but on average, she is still going to travel at 40 kilometers per hour. So we know her speed already. We also know from this question the distance we are looking for. We're looking for a distance of 180 kilometers. So what is it asking for? Well, it's asking for how long. In other words, it's asking for how much time. So that means I'm going to go back to my triangle formula here. I am looking for time. In order to do this, I have distance on top of speed. There's my formula, and now I simply substitute the values I know into the equation. I'm giving her total distance now in part B as 180 kilometers, and I've already calculated that the speed is 40 kilometers per hour. Quick mental math on the side here. 4 times 40 gives us 160. Difference of 20. 20 over 40 is 0.5, so I know that 180 divided by 40 is 4.5. You're welcome to try this on your calculator as well. Now we're looking at our units. Kilometers divided by kilometers, that cancels out to be just 1. The only unit I am left with now is hours. So my final unit here is 4.5 hours. Checking with my question, well, it is asking for how much time. So this works out perfectly. My unit should be hours. All right, looks like Erica is in for a long bike ride. For today's homework, make sure you are clicking into Homework and iExcel listed page. Once you go in there, scroll down to lesson number 5 here for speed and density. You will see a link that says Calculating Speed Homework. Make sure you do this during our posting session today. If you have questions, come on to Zoom.